In this lesson, we're going to examine polynomials in more detail, and we're going to start trying to make our graphs a little bit more accurate as we go through this. So yesterday we got the idea of leading coefficients, number of turning points, number of zeros, end behavior. Well, today we want to look more about those zeros themselves. Okay, so the factored form of a polynomial will take the format like a quadratic. Quadratic we used to have our a value, still do, our leading coefficient. And then we have brackets. Each bracket signifies a different zero. Okay, a quadratic had two of them, s and t. We add another one, we now have a cubic. We add another one, we get a quartic. You add another one, you get a quintic, and so on and so on and so on. S, t, u, v, and so on would be your zeros. Be careful, like previous with quadratics, when you take it out of the brackets, you have to change your sign. Okay, so if I was looking at this equation right here, my a would be 3, my leading coefficient. So I know right off the bat that this would be opening up to the right. Okay. If I count my x's, 1, 2, 3, it's an odd number. So I would know to the left, I'd have to be going down. Okay. I would know now that I have zeros of x equals 2, opposite sign, -4, and +5. Okay, so I can make my graph even more accurate than I had yesterday, where I just had an idea of 1 point. Well, now I got 3 points. The more points I have, the more accurate my graph will get. Okay, zeros can be different styles. There are different types of zeros. The zeros we're used to with quadratics, for the most part, are called pass-through zeros. So if your zero is written out of the bracket, x minus s, the graph is going to pass through and continue on. It's called an order 1, 0, and it's going to happen at the location of s. So for example, if I had x minus 2, x plus 3, and I don't know, x minus 1, I'd have zeros at 1, -2, and -3. Oh, sorry, +2. +2 there. And -3. And let's pretend, for instance, my equation looks like this. So positive on the right-hand side. I would have to pass through the first point, pass through the next one, and pass through the third one. Right? Go right through that and continue on. That's the kind of shape I would have. The next type of zero I could have is a touching zero. We also call these bouncing zeros, as we mentioned previously. You can tell if you see a bracket with a squared on it. These things will bounce off the x-axis. We call it an order 2, 0, or your book sometimes calls it a double root. So let's say I had an equation that looked like this. Okay, my zeros are still at 2 and -3. So here and here. My leading coefficient is a negative, so it's going down to the right. And I have a squared and a squared, and a squared times a squared makes a power of 4, which is an even number, so I go down to the left. Okay, so I have some idea about my leading coefficient, my end behavior, but the zeros both have squares on, which makes them bouncing zeros. So I'm going to bounce off the axis, come back down, bounce off the next axis, come back down again. That could be a picture of my quartic function. The third type of zero, we don't see very often, but will come up sometimes, is called a tangent zero. That's if you have a bracket to the power of 3. Okay? In this case, you're going to have a flat spot at the 0. The one we see most often, y equals x cubed, is really one of these examples. It's like x minus 0 cubed. This is our basic cubic function, right, which goes up, gets flat, and continues on. So this place right here just flattens out for a second. It's as if it's almost a turning point, but not quite a turning point. It's going to change direction. Oh, no, it continues on. Okay, we call these order 3 zeros. You can see other ones. So maybe you have a negative sign. You have x plus 2 cubed. So at -2, I'll be over here. I'm going down to the right. So I'm just going to do this. It's a power of 3, which is an odd number, which makes it go up to the left. So what's going to happen here? I'm going to come down, get flat, and continue on. Okay, that's called a tangent zero. So 3 different types of zeros we can have. Every time we add one of these ideas in, we can make a graph somewhat more accurate. And of course, you can combine functions that have all these in it. If you really wanted to, you could have a function look like, I don't know, 2x minus 1, x plus 2 squared, and x minus 3 cubed. And you could have all different kinds of zeros in there, and each of those would be doing something different. All right, we're going to try sketching some things. I want to sketch based on the things that I know. What do I know by looking at these equations? Well, my leading coefficient here is 2, and it's a positive. So a positive lead. My 0 comes from this piece here. Now, these are one of those zeros that's not nice for us. There's more than one number in there, but we know how we dealt with those in quadratics. We could deal with them the same way. My 0 is at 2.5. The value that makes that bracket come out to 0. What kind of 0 is it? It's a bouncing 0. Okay, so at 2.5, 1, 2.5 right there, I have a bouncing 0. I have a positive lead coefficient, so I have to go up to the right. I'm going to bounce off the axis, and my exponent is an even number on the x squared, quadratic, which means my left and right hands do the same thing. So it should look something like that. Okay, we try the next one. We have a leading coefficient that is negative. We have a 0 at negative 1. We got a 0 at 3. This one is a tangent 0. This one is a passing through 0. So we have one here, and we have one here. My leading coefficient being negative means I'm going down to the right. The fact that I have 1x and 3 more x's means I have 4 x's, or a quartic function, even number, which means I'm going up to the left. I need to think about the fact that this is going to be a tangent 0 at 3. So I need to go flat for a second. Okay? But then it has to continue on. Well, it's going to have to continue on to go up, but then come back down so it can go through this next 0. Oh, you know what? I wasn't paying attention when I drew that other in there, right? We said it was a quartic, so it should have same end behavior. Which, that's a way of testing, right? I said it should pass through. My end behavior wasn't matching what I thought should be going on, so obviously I had a mistake in there. There's one example of this function. Now, I could make this more accurate if I thought about my y-intercept. That would make things more accurate. We know about the y-intercept, that's where x is 0. So if you want to be more specific, point in there, we can start plugging in numbers and figuring what's actually going on here. Okay, so really, our y-intercept will be way up there. That's one of these things, right? But for our purposes today, my objective is to take the zeros in the leading coefficient and use that to get a good sketch idea of what's going on. We're going to try some more. Okay, what do we got? Leading coefficient is positive. This means it's going up. I've got a 0 at negative 2. It's going to bounce because it's the power of 2. I've got one at 1. It's also going to bounce. Let's draw those in. Okay, I need to go up to the right. I need to bounce. And it should go like that based on my bouncing idea. The fact that the power of 2 and a power of 2 makes it even exponents. My end behavior matches. Good, I'm on the right track. If I want to be more exact, I can figure what's happening at 0. Just to make sure I'm on the right track, I'll have 2 squared times negative 1 squared, which is 4. Oh, so really, if I want to make this really good, I could say 1, 2, 3, 4. I was pretty close. I had the right idea. I'm going to try the last one. I have a function. What I hope you recognize in this function is non-factored form. But we can fix that. Here's factored form. Leading coefficient is positive. I have a 0 at negative 2. I have a 0 at 0, and it's a bouncing 0. Okay, I have to go up to the right. I have an odd coefficient, so down to the left. I need to bounce off 0, so go back up and back down again. And you can make that smoother if you really wanted to. Something like that. Okay, some good ideas there. What if we want to work backwards? What if we have the information, we want to make the equation? Well, we can do that using the ideas we learned about in quadratics. The ideas in quadratics where if we know our zeros, we can always plug them in. So a bracket x minus the 0, change my sign, change my sign, change my sign, change my sign. The only thing I'm missing is the leading coefficient, which I can find if I know a value. So we're going to plug in what we know and solve for what we want, which is our leading coefficient, of course. -4, -3, -1, and +4. If you multiply that all together, we'll get what? 12 times -1 is -12, -48a, which makes a -0.25, or -1/4. Which means my function, my quartic function, what do we got? F of x equals a -1/4, -0.25, your choice. Then we have our zeros, x minus 3, x minus 2, x minus 0, and x plus 5. The order you put your zeros in is not important. Okay? Bracket, 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 smallest to largest, your choice. Okay? So we got it from our information. What about with a picture? Can you draw the same information? What do we know? We know. I don't know my leading coefficient, but I do know some zeros. There's a 0 right here at 1, 2, 3, 4, which means I have to change my sign. And 1 right here at -1. And it's a special one because it's bouncing, which means it needs a squared on it. I know a point, an x and a y, so I can put in my point that I know and solve for my leading coefficient. We'll get 4 times 1, right? When you square negative, it becomes a positive, which gives me 4a, or in other words, -1/2. Does that match what I think should happen for leading coefficient? Well, our leading coefficient is going down to the right, and it's a negative. So yeah, that makes sense. That should match. So our function is -1/2 x plus 4 and x minus 1 squared. And one other thing to point out, if my left-hand side is going down and my right's going down, my left is going up, that's an odd exponent function, odd degree. And if we look at this, I got a power of 2 and a power of 1, and obviously 1 plus 2 makes 3, which is an odd number. It matches what I think should be happening. It's always good to check. Right. Let's try C. Determine the equation for a quartic function. The zeros at 2 and 4, and a double root -1. The y-intercept is -4. And then sketch it. What can we do with this? Well, they didn't tell us the leading coefficient, so I need to solve for it. I've got a 0 at 2, opposite sign, another one at 4, opposite sign, and a double root at -1. Opposite sign, and to make it a double root, I need the squared on there. The y-intercept is -4. I know that's actually a point, so I can solve for my leading coefficient. And what do we get? We get -2, -4, and +1. Multiply it all together and we get 8a. So a is -1/2. Our function, -1/2. Go back to the beginning. We had our zeros, our double root. There's our information. They asked us to sketch this. So let's make a sketch. What do we know for sure? Well, we know that we had a 0 at 2, another one at 4, another one at -1, We were also told in the question the y-intercept is -4. 1, 2, 3, 4. We figured out our leading coefficient is a negative. It's going to do this. We were told it's a quartic function, so even. We were told that there is a bounce at -1. So I have to go back down, okay, through the y-intercept, and then I need 2 regular old zeros, pass-through zeros. Here's a pretty good sketch. Getting more accurate, right? The more information we add, the more accurate it gets. Okay, so there's zeros, leading coefficients, y-intercepts, equations, factored form. Okay, some questions you should try tonight. Make sure you can do some basic stuff. If you're stuck, come see me and we will work through this.